Folks, we're looking here at our Winter 21 question paper 6.1, and we're looking at question 5, which is one of the physics questions this time. We're looking at the focal length of a convex lens. As usual, I'm going to show you my answers and I'm going to compare them to the mark scheme. And I think it's really important to do this with paper 6. As you'll see, there's differences in terms of printing, etc., which might get confusing when you're using past papers. So, without any further ado, we'll start with the setup. We've got an illuminated object, a convex lens in the holder, and we're shown that the illuminated object is a triangle. Now, there's a lot to read here, as I've noted. It is worth taking your time just to make sure that you know what this experiment is about, because the more you kind of embed yourself in the situation, the more you can relate to the questions. Okay, now, the student is keeping the distance between the object and the screen constant, okay, places the lens close to the illuminated object, okay, and then moves it away until we form a sharp image. In other words, a focused real image on the screen. Okay, and then they show you here the position of the lens where the image is sharp. Now, if you notice, just on the bottom left-hand corner, I have done a little line there, that's U1. That's related to one of the questions which asks you to flick back to the figures and do some adding. So anytime you see the figures with perhaps no information, just be wary that you're probably going to have to add something to that figure yourself. Okay, we'll scroll through to the questions proper now. Now, first things first, we're asked to measure using a ruler. Okay, and we're asking to measure the distance U1 from the illuminated object to the center of the lens. I'll just scroll down a bit so you can see. That's this distance here, here on the left-hand side. Now, when I used my ruler, I measured 3.8 centimeters. I used a ruler with millimeter degradations and found that this the distance to be 3.8. Now, if you notice in the mark scheme, it's 3.9. Why is it different? Well, my printer is not the same scale necessarily as the printer used when this paper was originally printed. So you might find when you do these questions that it's a slightly different answer. Okay, don't worry about this. Okay, just trust if you're fairly close, you probably got it right. If you're way off, then you've probably made a mistake. And you're going to notice that my values are going to be consistently different to the mark scheme. Okay, as long as they are consistently wrong, consistently inconsistent, then we're okay. Okay, so you would get a mark there if you've marked that. You notice I'm 0.1 of a centimeter away, nothing too bad there. Okay, but just be wary, it could be different to the MS. The next question, I'm asked to use a ruler to draw a double-headed arrow to show the distance. Okay, and that's literally just the distance that we just measured. I've used a ruler. Okay, clearly I've drawn a straight line, and that again is important. Do not just draw this randomly by hand. Okay, after this is simply a bunch of calculations. Okay, we're told that the actual distance from the object is 5 times larger. All I have to do, okay, is simply multiply my numbers. So we've got to find the actual object distance, U1. I'm just going to use my calculator to multiply my 3.8, okay, which should come in at 19.0. Notice in the mark scheme it's 19.5, and that's because of this scale difference. Okay, I'll try and not keep on repeating that for you. You're then asked, given an equation, to put the numbers in, do a bit of calculations, okay, to find the focal length of the lens. Again, this is just a case of using what you're given, nothing too complicated here. We're then shown a diagram of the image on the screen, and notice if we compare this to the first one, we have an upright triangle. This is an inverted triangle, and we should know that when we use a lens, we will find inverted images. We're asked to measure the vertical height. Okay, and again, I've done that, and I've recorded the height in millimeters. So a careful thing here to check would be that you are expressing in millimeters, not in centimeters this time. You notice again, the value given in the mark scheme is 26. I measure 25. Scale difference is consistent. Okay, I'm going through this fairly quickly because I feel like some of these scales are fairly basic. Okay, we're just putting numbers in, as you can see for B1. Now this time you are given U2. Okay, and all you have to use is use their values, and this is the case where you can check your answers relative to the mark scheme because this is a given number. You haven't had to do any measurements, and so therefore you should be getting that one right. You're multiplying our 59.2 by 80, take away 59.2 and dividing by 80, getting 15.4. So if you're marking your own script, you will find that you should be giving your mark for that 15.4. You then again asked to measure the height, h2. This time I got it 8 centimeters, so there's a fairly consistent change there. Okay, and then you're asked to calculate the average value. Now we've got two F values, FA and FB. To get that average, we are going to add together and divide by 2. And I'm going to give it to 1 decimal place. I find 14.95, which is approximately 15.0, which is going to be my answer here. And again, I encourage you to show all your working. If you're nervous about significant figures, include 2 decimal places here and then round up to 1. Okay. We're then asked to calculate a ratio. You're given the equation for the ratio, which is R equal to H1 over H2, okay, which is 25 divided by 8, which is going to be, again, approximately 3.1. And there's no units here required because we're calculating a ratio. A ratio of centimeters to centimeters then means we have no units. Okay, racing through quickly here. Okay, we haven't really checked the mark scheme for a while, have we? Okay, if you compare my numbers again, my ratio is slightly different to that for the mark scheme. Again, we have slightly different values, so I expect that. What I don't expect is a difference, however, in my 5e. Okay, and this is where students get tripped up a little bit. The teacher tells us that the ratio should be 3. And it then gives us this statement, which can be confusing for students, that two values can be considered the same if they are within 10% of each other. What does that mean? Well, it means that there can be a 10% difference. As long as there's a 10% difference between the two numbers, then we consider them constant or identical. What we need to do is use our data to work this out. The way I've done it is calculated my percentage difference. I've got my actual value, 3.1, and the proposed value, 3. I found the difference between the two, and then divided by 3.0 to get 0.0333, which is approximately 3.33%. Now that means that they are within 10% of each other. If this number was bigger than 10%, then I would be saying that those numbers are different. However, because they are less than 10%, then I'm going to say that they are the same. And that's why my answer is yes. Now, if you notice in the mark scheme, we're looking for a yes. Okay. And we're looking for a calculation somewhere to prove that. Okay. So you cannot say that they're simply close together or they're very similar. You must give a numerical value here. All right. These kind of questions repeat each other a lot, so do watch out for those percentage questions. Let's have a look at our final bits here. A similarity. Okay, well, we saw they were both triangles. Okay, however, they had different sizes. One was very big, one was very small. However, both of them are inverted. I would suggest that we stay away from the idea that they're both triangles. I think that would be a fairly simple answer there. So if you've written that one down, think a little bit more scientifically in this. We're then asked, finally, to state a precaution, which means we can get more accurate results. Now, this is not a safety precaution. This is to do with making sure that our data is accurate. And the best way of doing that, as you'll see, it comes up again and again, we should repeat and average the results. Okay, so that's always got to come together, repeat the experiment and average. Now, we also have some other suggestions in the mark scheme. We can make sure we're moving the lens slowly and being more careful to make sure we get a good value of our distances. We could make sure that the room is darkened, okay, to stop any interference from other light sources, okay, and also make sure, control variable, that our object and lens is the same height. However, I would always go for accuracy, repeating the experiment. If it is not suggested anywhere that the experiment has been repeated, then we should always make sure we do so. All right, super quick there, guys, but I hope that's illuminating. You're seeing a model answer and the mark scheme here. As ever, please ask me questions if you have them, and if not, get on with some more practice. That's the best way to prepare for your exams. All the best.